Welcome, friends. We are in lecture 14, and today I will tell you one very interesting comment to find out the area between two curves. Okay, and the area under a curve, as you know, it represents some sort of integration of that curve, and the thing is like this. To explain what I'm going to do, it is suppose you have a curve here, say uh, x and y axis. This is x axis and this is y axis, and you have a curve, two curves, suppose. One is something like this. This is your fx, and another curve uh, is suppose this one gx. Okay, and this two could be any curves. Now, the thing is, if I ask you to do this integration, for example, any point on the x-axis, it is a x equal to, it is x equal to b, then this integral, that is fx minus gx whole into dx, starting from x equal to a to x equal to b, will be nothing but this area. Got the point? This area. Got the shaded area you will get. Okay, and so this is the shaded area is equal to the shaded area. Similarly, if you could draw another curve, suppose this is your xy axis, and if you have a curve like this, suppose this is fx, and the second curve gx is suppose this x-axis itself. That is, gx is equal to y is equal to 0. This is y-axis. This is x-axis. Y equal to 0 is gx. Then if you integrate once again from a to b, this one will be actually the integration fx dx a to b, and this will be the enclosed area, that is this one. That is, if you have a curve fx, then area under this curve with this x-axis, if you drop a perpendicular from these 2 points, you will get this area. And this is nothing but the integration fx dx. Fx minus gx, but gx is 0. So here in this one, gx is 0, is equal to 0 here. So this is the whole idea. That is what we will be doing in today's lecture. So to do that, I go to our GeoGebra uh, setting, and we do like this. Now, to do this, so I have to define two functions. So first, suppose I say that uh, uh, your fx equal to, suppose, y is equal to some parabola, let us say zero point 0.5 x square. So it is a parabola drawn, and this is my function f. Then you just say my gx is equal to y equal to 0, y equal to 0, and this will be this x-axis. Okay. Now I will take any 2 points on the parabola. So one point I say that P is equal to point. Point on what? Point on the parabola, that is f, and you return it, point P appears. And this point P will be restricted on this parabolic line. So it is there. Okay. Similarly, I create another point. Q is equal to point on the same parabola, that is f, and your Q is created, and Q can be placed anywhere you like. Okay. So PQ are the two given points, and then I want to integrate or find out the area. If you drop a perpendicular from P here, whatever will be the x value, that is the x coordinate of point P, will be the starting x value, and what will be the x coordinate of point Q, that will be the finishing x value, and then I will f minus gx is 0, so I will just do the integration. So here then I write that, okay, you see, it is the instruction is integral integral between, is it, it is not helping me, integral between, yes, it has come. So you just type this, then you select this option, integral between two functions, start x value and end x value you have to provide. So I choose this, and your first function is your f, then your second function is g, that is y equal to 0, this one, and the start x value is the x coordinate of point P, which can simply be written as, which can simply be, oh, I'm sorry, come here, we can simply write this as x of point P, and the finishing value is x coordinate of point Q, and I hope you are done. And if you put the return, it gives you the area and prints the value of the area here. So you can choose the scale a bit this way, that way, so that it looks larger, and this is what we intended. So area under the curve parabola, this parabola with the x-axis is this one, and this is nothing but f dx integrated from the x coordinate of P and x coordinate of Q. And you can now vary the creation of these 2 points P and Q, which could be anything, just to demonstrate. If you want to find out the integration from this limit to that limit, this will be automatically taken care of. Is that point clear? So this is very interesting and important instruction, that is integral between functions. So that we have done now. Now, after doing this, and this can be applicable to any functions. It need not be anything like that. So I just suppress this now. These are the things. Now, what you do, you draw another line here. Okay. Suppose the drawn line is, say, y is equal to, suppose, 0.5x, and give it, mm, add some constant to this curve so that it will look like this. And you see this curve is created, isn't it? This curve is created, and if you return, you have point of intersections here. So if you want to find out the area under this straight line enclosed between this straight line and the parabola, the instruction will be uh, simple, is not? Okay. Now, first, let me do like this, that I will find out. So I copy this instruction, copy duplicate input here. Now, I want to find out the integral between f, and not with g, but with h, that is the straight line. I write that, okay, h. And then I want to integrate from this point x coordinate of point P and y coordinate of point Q. And so xp to xq I will do. Let us see what it does. And it does this. This is indeed the area under between enclosed between this parabola and the straight line, and the total sum of these three areas is denoted here. Not really, it looks like a little less. Why? Because I have done f minus h. Mind you, when h is greater than f, it will, this area is treated to be negative. That's why it has become small. Got the point? So this area is calculated based on this one, that is, always remember this, that so that you are not under the any misunderstanding mode, because of the fact, when f is greater than gx, in those areas it will be treated as positive area, and if gx becomes greater than fx, then it will be treated as negative area. So what it does really is the, this is treated as positive because you have written, this area is treated as positive because you have written f is greater than h. So a minus h it does calculate it, and in this case, it does a minus h. You know, if is less, h is more during this zone, and therefore this area will be negative. That's why it has. So positive area, and negative area is also quite large, and it gives you the algebraic sum of these three. You should not be thinking that it is, suppose I want to purchase land of this area. This is the boundary wall of one piece of the land, this is the another piece of the land, and this is another piece of the land. Some of these three I want to purchase. Then of course this calculation has got no meaning. You are physically, you will be getting those areas, so you have to calculate this area separately, and during this zone you have to do perhaps h minus f from this to this, and from this to this you have to do once again f minus h. I think you have got the idea. So it gives you the algebraic sum of the areas. whoever wins, whoever is greater than other functions in a particular interval, the area may turn out to be positive or negative. And since I have integrated from P to Q, for example, you see, if you bring P down to here and Q down to there, this area itself is minus 5.8. It is indicating minus because of the fact you have done F minus F minus H. You have done the first function minus H. You should just keep that in mind. Hope you have understood this. And this is how things goes on in calculating the area under a curve. Okay. Now, another example I will just give, and then I will stop today's lecture. Clear all, don't save anything. Suppose you say that you have a function, say sin x. It is plotted, and then you have another function, say, what y is equal to x. Oh, it becomes a tangent, so make its slope less 0.5x. I want to find out this area, just another extension of that curve. So I must know the coordinate of this point and this point. This point is of course from 0, 0. Suppose I have decided I will calculate it, or I first find out 2 points on the sine wave. So create 2 points on the sine wave. The so P is equal to a point, POINT, a point where on sine x, that is F, it is created, and P can be moved anywhere you like. Okay, you can move P, and its movement will be restricted to sine wave here. So you keep it here, and then you create another point. Q is equal to point, point, and on same function f. Okay, and this is Q created, and this Q could be anywhere you like. Okay, I want to find out if I now write down this instruction, and that is integral between two functions. So two functions are, one is if the other function is g. So g, and suppose I want to integrate from the x coordinate of p here, whatever is the value of x, up to this point q. So it will be f minus g comma, then start value of x, it is simply x of p, then the final value of x, that is say x of q. Done. So this is the area. If I make it slightly exemplified, it will be better. So this is the net area. It shows minus 2.1, something like that. Why it is minus 2.1? First, I bring P here, suppose here, at the origin. Up to this point, I want to do the integration. So A minus G is always positive, and you get a positive area here. How much it is? 0.42 unit square. Because F is always positive area. be positive. Okay. Now, if suppose I keep P same and you bring Q down, you start discovering that the value of the enclosed area is becoming lesser compared to where when Q was here. Nothing is to be surprised about it because during this interval the function uh, if that is the sign ordinate is less than the function g ordinate. So g is greater than f. That's why this area is negative. So this area, whatever it was there, minus this. You can easily verify that. And you can put it here, wherever you like, and your net value of this integrated results will be displayed. So I think you have got the idea of integrating a curve. And of course, you can integrate the sine function under x-axis. If you want to do that, suppress this g. I don't want it. And also suppress this integral business. And then what should I do? I should create a function here which will be x-axis. So y is equal to 0 will be the x-axis. This is the red color. And I want to find out the area under this sine curve from P to Q. So you copy this here, duplicate input, same thing. Nothing is wrong. But only this time it is the area under the curve F and what? Not G, but what is this H? You do it, and you see you get the net area here from P to K. And note that I am doing f minus h. So here this area is negative, it is showing. And here the area is positive. Positive area is greater than this area. So net result is positive. And this you can shift P to demonstrate that area will be become only positive during this zone. And you can bring it here. It will be like this. A very nice way of showing the areas under a curve, and it is indeed the integration of sin x dx eh, between p to q. And you can, for example, I will make it slightly smaller. If you bring q down to starting point is p and this one is 1, you can easily show that this positive area and negative area are equal, and some of the areas are 0. Okay. So I stop here today, and I hope you have understood the uh, about the integration a particular function over a certain range, what it means, and don't forget that there exists a beautiful and simple instruction. And as I am telling you repeatedly, you write few words integral, then it will give several options. And it is the option I have chosen is two functions and the limit of integration, that is the x coordinate of some points. I have made p and q restricted to that curve so that I can change the interval at my own will. Okay, thank you. I stop here today.